Hello friends and students. So here we will try to find the equivalent resistance of an infinite ladder network. A very common question which keeps appearing in examinations and also in most of the entrance exams. So here we have a network R1, R2, again resistance R1, R2, and this keeps on continuing up to infinity. And what is the equivalent resistance? So we need to find the equivalent resistance here. Now before we try to find the equivalent resistance, the problem is actually very simple, right? So before we try to find the equivalent resistance in such an infinite ladder network, we need to identify the unit element. So we find that the element R1, R2, so this element keeps repeating. Now to find the equivalent resistance, what do? We consider this infinite ladder network with one of the elements. That means I remove one element from this infinite ladder network and I consider that resistance, equivalent resistance, as R equivalent. Now from an infinite element, if I remove one, I'm still left with infinity, isn't it? So infinity minus 1 will be infinity, and later when I add one element to the infinite set of elements, it would be infinity, because 1 plus infinity would again be infinity. So now let us consider all these elements here as R equivalent, assuming that we have already found the equivalent resistance, and that is equal to R equivalent. So I have A, B, so I have the resistance R1 along with resistance R2 and this infinite ladder network which exists, and the equivalent resistance of this infinite ladder network, let me call that as R equivalent. So we just have to remember that if I need to find the equivalent resistance, we consider one element apart from this entire ladder network. So if I remove one element from an infinite network series, it does not change, isn't it? So you still have infinite elements there. So this problem actually reduces to a problem where you have two resistors in parallel in series with the resistance R1. So what is the resistance RAB, which is nothing but would be equal to the resistance of the entire infinite series, isn't it? So that would be R1 in series with R2 in parallel with the equivalent resistance. So what is RAB? So RAB would be R1 plus, so I have R2 into R equivalent divided by R2 plus R equivalent. So two resistors in parallel, so it's going to be multiply both the resistors and add both of them. And what is this equal to? So this is nothing but equal to R equivalent. So RAB is nothing but R equivalent, isn't it? Alright, so now let me consider this expression here. So let me take LCM. So this implies that I multiply R1 with R2 plus R equivalent, so I get R1 R2 plus R1 R equivalent plus R2 R equivalent, and I'm multiplying the denominator with R equivalent, so we get R2 R equivalent plus R equivalent the whole square. So now I cancel R2 R equivalent on both the sides. So now what do we get? We get R equivalent square minus R1 R equivalent minus R1 R2 equal to 0. So here what is A, B and C? Let me list it out. So A is 1 and B is minus R1 and C is minus R1 R2. Okay, so therefore R equivalent is nothing but minus B plus or minus root of B square minus 4AC divided by 2 into A. So we have minus b. So b is r1 with a minus sign, so I get plus r1 plus or minus root of b square, so I have r1 square, minus 4 into a is 1 into c is minus r1 r2, so it becomes plus r1 r2 divided by 2 into a is 1, so I get divided by 2. So we have r1 plus minus r1 square plus 4 into 1 into r1 r2 divided by 2. So I have the equivalent resistance as R1. So of course we do not consider the negative sign because resistance is always a positive value. So we have R1 plus root of R1 square plus 4R1 R2 divided by 2. Now if these two resistors are equal to R, then what happens? So this is R plus I have R square plus 4R square. So it becomes 5R square, so I get R into root 5 by 2, or it is R into 1 plus root 5 by 2. So the equivalent resistance is R into 1 plus root 5 by 2, and if the value of R is 1 ohm, so then I get the equivalent resistance as 1 plus root 5 by 2 ohms. So this is the answer. So in general you can remember the expression as R1 plus root of R1 square plus 4R1 R2 by 2. Or if both the resistors are equal, you can just remember this expression as R into 1 plus root 5 by 2. And depending on the value of R, if both these resistors are equal, depending on the value of R, you can substitute the value and get the equivalent resistance. Right? So to find the equivalent resistance in such an infinite ladder network, in any given infinite ladder network, just remember you just remove one of the elements and still you have an infinite ladder network. So you call that as the equivalent resistance. Okay, and then with that single element we find the equivalent resistance, and that also would be equal to R equivalent, because to infinity you add 1, it still remains infinity. So therefore REB is nothing but R equivalent. So we can mention that here. And this is how we find the equivalent resistance. So I hope you have found the video informative. And do not forget to view all the other videos on network analysis by clicking on the I icon or going through the playlist network analysis. And do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads. And thanks for watching.